Now, we left off 1.3. 1.3 only had a little bit of information on random samples, so that's the only thing out of 1.3. I didn't see anything else that's very important. There's different types of samples. Now, the reason you need to know different types of samples, again, like I said, if you go to Math Science 301, you're going to be doing more surveys than you will in a basic statistics course. So you will need to know what the different types of samples are. So as far as random sample, you need to know for a test question. Okay. These samples you just need to know for your information and for homework. Stratified sample. Talking about grouping. Okay. I would say a stratified sample would be like a voting precinct. If you wanted to go out and survey voters, instead of going all around Anderson County, you could go to one of the voting precincts because they're already what? Grouped. They're already there. So you can sit outside the door and say, who did you vote for? Or what party did you vote for? Something like that. So that would be a stratified sample of voting precinct. You could think of it as a sample, but the reason it's not a sample is because it's got two groups in it, or three groups, depending on how many different parties are represented. Republican, Democrat, Independent, Libertarian, depending on how many, you take the first question you would ask is, what party do you align yourself with? And then they tell you. And then from that information decides how many different subgroups you got in that precinct. Okay? So that's a stratified sample. Just for your information and homework. There's one other. There. This is a test question. Systematic sample. A systematic random sample is if I go through the class and instead of you filling out a Post-it note, every fifth person, 1, 2, 3, 4, 5, every fifth person fills out a Post-it note. And then I put those Post-it notes into a fishbowl. That's a that's a systematic random sample. That's a test question, and it's probably more random than the random sample. Some people would rather do a systematic random sample in the survey rather than a random sample, because you never know what you're going to get with a systematic random sample, because you're counting every fifth person or every seventh person or every person last in the phone book, or every person, every last name on each page of the phone book. That would be a systematic random sample. So you don't know what you're going to get. So yes, sir.
So I remember one time I was doing this thing for voting. You had a voting thing. You had this phone. It was like pick random people's numbers.
Yeah, robo.
What kind of
robo dial? That would be a systematic random sample. What it's doing is evidently the computer is hooked to the phone, and there's a program in there dialing each so-and-so number in the phone book. Yeah, well, then if it called every landline, then that would be a random sample. Certain people would be systematic, but you'd have to ask whoever you were doing it for, you'd have to ask what it's set on, what it's programmed on. So, but it sounded like to me it might have been a systematic random sample. And usually, why would you do a systematic random sample over a random sample? Two important things: time and money. Systematic random sample will give you the random sample, but also cut it in a fraction of the time. Okay? So that's why a lot of people use systematic random sample over random sample. It's about the only one that you use over a random sample. Convenience sample, which will probably be next, is the least, if they even show it, no cluster sample. A cluster sample, I'm trying to think of a good example of a cluster sample. A cluster sample would be like going to Walmart. Okay? Now, what's the difference between a cluster sample and a stratified sample? Well, a stratified sample, everybody's there within a certain what? Party. Okay? And a cluster sample, like going to Walmart and standing outside the door, there's all kinds of people in Walmart. You know that, especially the LA Walmart. Okay, you never know what you might get at LA Walmart. But I hear Liberty Highway is getting even worse, so I don't know. I guess crackheads go everywhere, right? Except Target. They won't go to Target. Target, they're going to follow law on you. Okay, cluster sample would be like a parking lot. Huh? Nah. Main random sample and systematic random sample would be a test question. But you need to know these terms because you might see them again if you go into another statistics course. There should be a convenience sample in here. Least reliable. Convenience sample. Let's say you work at a radio station and you're the DJ and you decide your statistics teacher wants you taking classes on the side and you got to do a survey. Well, instead of doing a survey, you just say, okay, to all my listeners out there, call in and let me know what type of music you like. Well, you work at a rock station. What? Everybody's going to be what? Rock. Okay, so that's a convenience sample. That's why a convenience sample can be less accurate or least accurate. But it's easier. Hollering out to somebody outside your window. You know, hey, do you believe in blank? That's a convenience sample. You're not taking much time preparing. There's an old saying, and it's very true in 100% of the application. You get out of something what you what? Put into it. Okay? And you can't make chicken salad out of chicken poop. All right? I know some of you roll your eyes at me on that, but it's true. If you take a survey and you don't put anything into it, then your results are going to be crap. Okay? Y'all can apply that to just about everything. Okay. I remember being a student one time and the teacher saying stuff like that, and you roll your eyes. There's some examples of the samples right there, just some graphic examples. I'm not really, that may help some of you. There's a systematic, and there's a random. Now, what about everybody's got a chance, simple random sample. Everybody's got a chance of being picked. That was the fishbowl with the Post-it notes. These two right here are the most used. Okay? That's 1.4. Why don't they just put all this in one section? Good gracious. Divided up into 4 sections. It could have been just 2. All right. How many collections in chapter 1 we cover? You got your outline with you? Huh? 1.5. Is that 1.5? Heck, 1.5 must be short. I disagree with dividing. This is a test question and is a very important word. What is that word? Bias. What does that mean? It means you lean toward one side. This is the bad word of probability and statistics. Okay? This is what you have to be aware of, not only as a statistician or a person doing a survey, but you have to be aware of it as a viewer. When you look at or listen to certain things being presented. Okay? If I tell you that I went across the United States and I've surveyed people across the United States, and I have found that the next president will be Mr. Smith, okay? And he's a Republican, and you say, well, I don't believe that. Well, I went across the United States. I went from South Carolina to Georgia, to Mississippi, to Alabama, Louisiana, Texas, and then I took a train from Texas to California, South California. So did I go across the United States? Yes, I did. I went across the United States, but I went across the mostly conservative what? States. That's bias. You know, you can do bias in front of a survey, meaning pick out the places or the people you want to do before you start, or you can do bias as you're calculating and interpreting the what? Data. Give me an example of bias. You got any real world examples? Yes, sir. Yeah. There was a big, I mean, if some of you watch the news, which I know probably 80% of you don't, okay, you need to start watching, because our country was run by the media up until this last election. Okay? Whatever the media said to vote for, that's who the United States went out and voted for. That's who we went out and voted for. Okay, we'll go out and vote for them. Okay? Because we believed the media. But now the media has been exposed. Okay? Some of the media has been exposed as being unreliable. And you have to watch. Are they covering the real news, or are they covering junk? You know, what's going on in the real world. And for you to have to go to find out what's going on in the real world, you have to go to different sources now, because you really don't know. I mean, think about it. If all the news is telling you stories, then do you really know what's going on in the world? So you need to dig around a little bit, do some research, find out what's going on in the real world. Who just shot off another missile? North Korea. This time over what? Japan. That's not a smart thing to do. Okay? Japan is not this little third world country. Okay? It doesn't have people starving like North Korea does. Okay? They can't eat nuclear weapons. That's why they're starving. Bias. Watch out for bias. Okay? If they could eat nuclear weapons, they would be okay. But all that money that they've been given through the sanctions and through the anti-sanctions has been going toward nuclear weapons instead of feeding the people. That's why the people over there are starving, except for, what's his name? I don't think he's missed a meal. Watch out for the bias. I'm not going to go into response bias. Just make sure you know what the word bias meant. So, like, this right here is an example of a biased question. Do you oppose the reduction of estate tax? Why is that wrong? Because you already given the person a way to go. You're giving the person, you're tending that person to oppose it instead of leaving it neutral. The best word in probability and statistics is neutrality. Okay? Not bias. The opposite of bias is neutrality. Yes, sir. Just the one below it. Do you favor or oppose? Or do you oppose or favor? You just leave it open. It's kind of like this. Why is it difficult to lie? Why is it more difficult to lie than to tell the truth? Exactly. And the same thing is with the bias, okay? If you open that up, it's like opening up Pandora's box, all right? You've got to cover that question and another question down below it. Because you've got to, if you want to swing somebody the way you believe, you've got to not just give them one question, you've got to give them what? several questions, and they all have to be biased. It's kind of like opening Pandora's box. You can't close it. And that's why it's such a bad thing in statistics, because especially if you're in a subjective type statistic. Now, if you're in a numerical type or quantitative type, like how many tires does Michelin mess up, then it's going to be hard to do. It's going to be hard to be biased there, okay? Because if you're biased one way, you're going to lose your job. Okay, if you're biased another way, then you're going to have a surplus in next year's budget because you didn't do your job right. Okay, so you know, if you're a quality assurance person anywhere, and you could be a quality assurance person just like that, somebody can say, we want you to do the quality assurance for our department this year. Okay, or you could be a quality assurance executive. So somebody could stick it to you, whether you're in a nursing field, whether you're in an industry, or whether you're in engineering. Somebody could stick it to you real easy. I want you to do the quality assurance for what we're putting out, or how many people are being safe, or how many people died last year on site, you know, or injured. You could be stuck with it just like that. So just telling you, don't be biased, be neutral, and try to be down the middle. Okay? And if you ever go into another statistics course, there's a whole chapter on this. Okay, here's an example of an open question. It allows the respondent to choose his or her response. What is the most important problem facing America's youth today? And then over here, a closed question, it kind of hinders it. That you don't want closed questions on your, unless it's something quantitative, like socioeconomic status. Which level do you consider yourself? And then that would be an okay question, because you always have below 30,000 a year, and then you always have above 240,000. So you can leave it open and have the middle area. You see what I'm saying? And that's quantitative. But you could do qualitative and say, you know, this question, well, that may not be what you don't have another. Now, if you had another, like F, other, and then put a blank, then that covers being an open question. Okay? So it's kind of like somebody being closed-minded. You ever met somebody who's closed-minded? Okay, same thing. Closed-minded people, you can't have a discussion with them. Because what? It's their way or what? The highway. How many of you have had a discussion with somebody that is either ignorant or very closed-minded? And what did it end up being? You end up getting so frustrated because the person is so closed-minded, you can't have a discussion with them. Same thing there. Huh? Yeah. The more ignorant you are in politics, the sooner it will show. I'm serious. If you don't watch the news and you don't do your research, don't get in a political argument, because you're going to end up losing because you don't know what you're talking about. I've seen that many times. I mean, all you got to do is turn on the news and watch. What is that? Antifa. You ever seen an interview with an Antifa person? Oh my gosh, they're dumb as a rock. Anti-fascists. They're the people running around with their mask on, being paid by George Soros. Oops, shut up. All right. So that's 1.5. So that's all your vocabulary stuff. So write that down as vocabulary. Now we're starting to go into some math, a little bit of math, not much, but a little bit of math, and then we'll go into chapter 3. So where we go, 2.1? Frequency distributions. Frequency distribution is a 25-cent word for a table. So out here beside this definition, you need to put table. Blondes, brunettes, and redheads. Let's say I go through and I count blondes, brunettes, and redheads. I know we got 2 in here, maybe 3. All right, three redheads, and then just overlooking maybe 4 blondes, and the rest of us are brunettes. Okay? The rest of y'all, sorry. The rest of y'all are brunettes. The classes on the left, blonde, brunettes, and redheads, those are classes. What's on the right is called the head count. The head count should equal N if when added up. Remember, the summation of the head count, the summation of the frequencies is equal to N, because N is how many people are in what? This room. Okay, make up the class. So, everybody with me? Y'all have got to start drinking Mountain Dew when you come to my class, okay? I'm getting tired of these yawns, all right? I'm too loud, and I'm not that boring, okay? All right. And y'all need to go to bed before 12 o'clock, because I tell my son. Relative frequency. Relative frequency is the frequency over N. Okay? The frequency over N. So, I've got 3 redheads in the group. There's 30 people in the class. So, that's a relative frequency of 0.1. 1/10. Okay, write that down because that's a test question. Always put the number over the total. So I think we had 4, I think we said 4 blondes. I'm looking just over 4 blondes, maybe 5. 5 over 30 would be 1/6, which would be, type it in your calculator, 0.16 or 0.17. Capiche? Do y'all understand? Okay.
So you put the number of redheads over the total.
Over the total, yes. I thought I gave y'all, I said to write it down. Oh, that must have been the first time you were yawning. You can't log on to Skype for Business with the only way you can get on the Skype for Business is go through the office portal, which is on your handout, and put in your what information? Tri-County Tech information. All right? Your Tri-County Tech information is not what you make up, okay, like Donald Duck Quack. All right? It is H. McClure or J. Smith. So when you write me a text and say, okay, I'm ready, my username is Red Fox. That's telling me that you haven't followed any of the essay directions I've given you. And these people vote and procreate. That's what you get for trying to install a very important program 5 minutes before class starts. Irritating, very irritating. Bar graphs. What does a bar graph look like? Well, y'all should know what a bar graph looks like. You don't have to write the definition of a bar graph. Just make sure you know what a bar graph looks like and how to read it. All right? So, how many people are in this rehab class? No. Spell mom backwards. 30. Okay. 12 plus 2 is what? 14. 14 plus 1 is 15. 15 plus 2 is 17. 17 plus 4 is 21. 21 plus 5 is 26. 26 plus 2 is 28. 29 and 30. So N is equal to 30. In the second group, I don't know. It should be the same. I don't know, but you can count it to see. You should be able to read a bar graph. That's all you need for the test. Okay? You might see one on there. You're going to see a pie chart also. Here is for your information and homework. A Pareto chart is a graph whose bars are drawn in decreasing order of frequency or relative frequency. So it's still a bar chart, but it puts your data in what? Order, and it goes like this. I don't have much use for a Pareto chart. The only reason I'm bringing it up to you, it's not a test question. It'll be a homework question, or you'll see it in another application in another class.
Is it always going big to little?
Yeah, decrease in order. Horizontal bars, that's the same thing. I'm not going to test you on that, but you should be able to read it. Like, that's his relative frequency. I wouldn't do. Okay, pie chart. Write that down. That's another test question. So you got a bar chart and pie chart. You know there's going to be one of those on the test. Make sure you can read it. Now, how do you read a pie chart? A pie chart is usually in percentages. Okay, if you make $1,000 a month and 20% of your paycheck goes to gas, that's $200 a month. $1,000 times 0.20, 20%. I'll give you an example down here somewhere. Right here. This is educational attainment. So you'll have to read over here what this means, but I guess the workers at a place of employment are surveyed and found out how much education they have. So if there's 1,000 workers, and I use 1,000 so it'd be easy math for you, but it could be 1,230 or it could be 2,468 workers. But whatever the total amount of workers are, you multiply by whatever they're asking for. So if I give 1,000 workers, 12% are not high school graduates, then that'd be 120. Multiply 1,000 times 0.12. Okay?
Is that why they write it like that?
Yep. But make sure you can read a pie chart. Now, I'm assuming a lot here, but there are people that graduate high school that can't read a freaking tape measure. All right? I'm assuming that you've had exposure to a pie chart in K through 12. I'm assuming that. All right. And that's 2.1. 2.2, do we go through 2.2? What do we cover in chapter 2? Okay, 2.4. And then we get into the math. Let's see what's in 2.2. Probably going to be class width and all that good stuff. Yep. All right, now I'm just going to let you look at this set of data right here. Number of arrivals at Wendy's within a certain amount of period, a 15-minute period, or whatever the case may be. So they're looking at 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 40 Wendy's stores. Okay? And they're timing one 15-minute interval. How many people come in 15 minutes? All right, now what do you do with this data? Well, the first thing you do is put it in what? Put it in a chart or order. Okay? So you put it in order. And then after you put it in order, you decide what kind of classes you want. That's what they do here. Okay? Here is your frequency table. Here is your classes. Here's your head count. Or right here. So, how many, in 15 minutes, how many of the stores had one customer come in? One. How many had two, and so on. Okay? And then you do your relative frequency here. So, these stores, there's 11 stores that had 6 come in. They must be doing pretty good. Okay, 11 stores, you would probably say that those 11 stores are probably beside the hospitals, like Anderson Hospital, okay, or beside a college, because they're having people come in all the time. Whereas this one, 7, let's say 10, they don't have any stores, they don't have any 10 coming in. You got one with 11, that one might be at a mall or something like that, you know, with 11 customers coming in every 15 minutes. That might be at a mall or inside a food court or something. Just saying. All right. Now, how do you figure that? You got to put them in order, and then you got to figure your classes. We're not going to figure classes in this class. All right. That's for a class that you're going to actually do research in. This class, the classes will be given to you. So all you have to do is put them in order, count, and do what they're doing right there, find the relative frequency. Okay? A histogram. Do you know the difference between a histogram and a bar chart? There is no difference. The only difference is they touch. That's the only difference. So the bar chart and the histogram are basically what? The same thing. Yes, ma'am?
So all the letters are in
It can be in decimals or percent, depending on what they ask. The directions will say. Doesn't matter, I'll take both. If you, and this is, I was going to sneeze. I've been sneezing like crazy the last couple of days. Has anybody else been sneezing like crazy? I think it's something to do with the seasons. If you ever have a problem on a test, let's say you do a test or homework and you put in 0.25 and they want 25% and the directions do not specify that, then I'll make it right. Okay? If the directions specify, then I really can't make it right because you can't follow directions. Okay? So remember that. Because I know somebody is not going to follow directions and they're going to put a 0.25 and the directions are going to say put in a fraction form, 1/4. And you're going to come to me and say that's the same, and I'm going to say you didn't follow directions. Okay? But if it doesn't have directions specifying, then I'll probably make it right. Okay, let's look at this example right here, table 10. I'm going to go through and pick out what is what on table 10. The lower class limits are on the left-hand side. The 25, 35, 45, 55, and 65, that's your lower class limits, so write that down. Draw an arrow, draw this in your notebook, and draw a brace on 25 and through 65, and say left-hand side equals lower class limits. What's 34, 44, 54, 64, and 74? Upper class limits, yes. Now, I don't really care too much about that. That's more of a homework for your information question. But this one you have to know, class width. Now, the best way to find the class width is to subtract vertically. What's 35 minus 25? 10. What's 44 minus 34? 10. What's 45 minus 35? the class width of this frequency table is 10. Now the reason I tell you not to subtract linearly is because you might think 25 minus 34 is 9, but it's not. As far as the class width goes, there's 10 spots here. But you don't see those 10 spots as well as you see them here. You see what I'm saying? So always subtract consistent class limits. That means one right after the other. Always subtract them vertically. Okay? Okay, here's the way, okay, I want you to put this down as for your information. On page, I don't know what the page, because for some reason this thing's got X's, evidently there's a plug-in problem. But whatever page this is on, make sure you make a note of that. Oh, I'm sorry. What? Page 78. Okay. Make a note of that because you might see it in your homework, and the class width is your range over the number of classes. The top of the numerator is called the range, the largest data value minus the smallest data value. And don't worry, we're going to go over all this. As soon as we get to the math part, we'll go over all this. That's how you determine the classes. Okay. So if you take the highest minus the lowest and get 0.9, you got a class width of 1. So that tells you that your class width is going to be 1. So 20 to 20 point, well, it's going to be in decimals because it's only class width of 1, so it's going to be very close. 20, 21, 22, 23, 24. So it's going to be numbered like that for your classes. It's really a crappy example to use, but anyway. Stem and leaf. Go ahead and write it down. You won't be tested on it, but you need to know what a stem and leaf. Well, I thought they'd show a picture of it, or hold on, let me see if we got it on the next page. There's a stem and leaf. You have data, and let's say your data ranges from 80 to 220. Then you chop off the tenths and you put the hundredths on the side. 80, I meant the tenths. 80, that's an 8. 90, that's a 9. 10 is 100. And then you count. So in your data, you have an 86, you have a 96, you have 105, 108, 105, 101, 102, 106, 100, 105, and 107. And then 112, 116, 110, 116, 115, 118, 120, or 112. And see the 12 spot, that's 120. So that'd be 125, 129, 125. So this is just a way to organize your data. Now you can see, if you take your handy dandy, you can actually see if there's any type of curve. This is skewed right. Why is it skewed right? Because this is the center and all the data is on the what? Left. If the data is on the left, it's skewed right. If the data is on the right, it's skewed left. So if this was let's say this was a test, then that means that most people what? Failed the test. So that means the test is invalid, or the teacher didn't do their job, or all of y'all went out and got drunk instead of studying. Okay? One of those three things, if not all, happened. Okay? Do you have college classes with skewed right data on their test? Yes. I'll let you fill out the blank on why. How many of you have seen test averages in the 40s? 30s? Wait to psychology and some of your other classes where they like to put up the class averages and the teacher sucks or the environment sucks. The average, class average goes, okay? But that, you could actually see that. This side over here, same thing. Why they what? I didn't understand you. First of all, speak up. These? They're separated in tens. 80, 90, 100, 110, 120, 130, 140. Just a way to keep from having to write it like this. Well, let me get my... Go to the previous page. See all this data? That's just a different way of writing it. Just putting all that data into this compilation set. Okay? Question, gripe, complaint. All right, some of y'all hard to read. Some of y'all look like y'all weaned on a pickle. I hope y'all know what weaned on a pickle looks like. That's what weaned on a pickle looks like. Some of y'all need to drink a Mountain Dew in the morning. You need to turn on a SpongeBob song on your radio, come down the road, and you need to smile, okay? Because y'all look real bad, okay? Some of y'all look like you weaned on a pickle. All right. I mean, I got to teach y'all, and I got a smile on my face. What if y'all had to teach y'all? Y'all would look like weaned on pickle. Y'all be like, shut up. I'm gonna fail you. Dot plot. Dot plot is just another form of a stem leaf plot, except instead of going to left to right, it's going up. It's going like that. So yeah, you can really see that the data is looking like a curve or whatever. Skewed to the left or skewed right. They're just showing you different ways to write your data instead of a bunch of numbers in a box. Okay? And here we go with identify the shape of the distribution. There's 3 particular shapes. Well, 4 if you throw in uniformity, which you don't get uniformity unless you're dealing with time. So that's uniformity. Normal, skewed right, and skewed left. So say I give y'all a test and everybody makes the same grade. And y'all a bunch of cheating, you know what? That's what it is. All right? That'd be uniformity. That's not going to happen because nobody thinks the same. The only thing that you're going to get uniformity in is anything having to do with time, because you can't change time. Can't speed it up. I want to hurry up and drive. I want to hurry up and drive. And you can't slow it down. Mothers trying to wear their kids' clothes. Doesn't work out that way. Y'all seen that commercial? I don't know what, it's a Verizon commercial where the girl goes, yeah, I rummaged through your closet. She's babysitting. That's so funny. And she says, is that my high heels? Yes, we're the same size. In shoe size. Have you ever been to a dance recital or a cheerleading competition? Some of the moms are pretty sad. Don't go. Those moms, some of the moms try to dress up in the girls' clothes and look like a teenager and they're 40, 50 years old and they look good. Some of them look like Oompa Loompas, orange face and a white neck. You know what I'm talking about? Too much makeup. Next. I think that's it. For 2.3 or 2.2. Yep. 2.3, I think that's where we start getting into a little bit of math. I thought we were, but they changed the book evidently. Is this a new book?
This is from the misrepresentation of data.
Oh no, that's not math.
And we do 3.1, that's measures of super tendency.
Yeah, that's where we get the math. Is this a new book?
Yeah.
That's why I'm mixed up, because they've done changes. All right, make sure you make a note of this word, misrepresentations. Now, when you look at these pictures, and you'll see several of these on the test, they're just going to be pictures, all right? And you have to be able to ascertain whether they're true or not. Now, what do I mean true? Well, let me find one that's pretty easy. And this is where your bias comes in. The ones I'm looking for are what's called pictographs. Okay, here's one. How we flush a public toilet. Yeah, there are people that study this kind of stuff. All right? Use your shoe. Act normally. Paper towel. What does act normally? I guess that means use your hand. I don't know why they don't say use your hand. Some people take a paper towel. No, you just pick your foot up on a urinal. I mean on a toilet, they have them so low to the ground you just use your shoe. You've never seen that before? Oh yeah, people do that all the time.
People like open the doors.
Yeah.
You're about to go wash your hands.
People use the shoe because one, the thing is so close to the ground, you just hit it. I'm not talking about at your house. Okay, your house, the thing's up here. Okay, no, you're not going to do a high kick to turn. No, I'm talking about one of those public restrooms, but now they're all laser induced, so it doesn't matter. And you're not going to do a high kick for the urinal and no, that's not what we're talking about. Now, the act normally sounds kind of weird. Okay, I don't know what that means, but I think that means take your finger and flush it. And then the paper towel, some people, before they go into, these people are just strange. Anyway, they'll go into and they'll get a towel before they use the restroom. And then when they flush, they'll take the towel and they mash the. I do it with door handles sometimes, especially if it's game. If the restroom, if it's emergency and it's a dadgum KKK looking place and dadgum, yeah. It's like go in, use towels and go out and smear all that soap on your hands and dry it later after you get out of the restroom. Okay, that's yeah. Anyway. But look at the, first of all, what's wrong with the graph? There's 2 or 3 things wrong with the graph. Doesn't add up to 100. There should be something that says other or etc. or did not reply or something. Okay? And what else is wrong with it? No. It's just not complete. The graph is not complete. It doesn't have a lot of stuff on it. Okay? Yes. Oh, I'm sorry. That's what happens when I start zooming this thing in. I need to set it back, and then somebody on the back row will go, I can't see. And he could let up in the front of the class. There you go. You could argue that the distance between 17 and 30 and 41 is not correct. You could argue that. Because 17 and 17 is 34, right? Okay, so it's about half. But it doesn't look like half from 17 to 30. See, that's one of the biggest things. And let me tell you what happens. You got a statistician that works at the Washington Post. The statistician writes down the data and sends it over to graphics. Well, the graphics person don't know a damn thing about statistics. But the graphics person puts up a pictograph like this, and they just put it up there and they just put the numbers in there. That's the way things happen, and you are getting bad representation on those numbers. That's not the best one. The best one is when they really screw it up. Let me find one. Oh, here's one. All right, now tell me what's wrong with this one. Okay, hold on. Let me. If you can't see, you can sit your butt up in front. Okay. I'm not playing with this thing all day gum plastic. There. All right. It says. Well, you can read the top. It says soccer in 1991 there's 10 million. In 2009 is 14 million. So it's still unpopular. Okay. Now I'm just kidding. Why is there a problem? Well, there's no numbers. There's no numbers on the actual pictograph. That's one thing. But that ain't what I'm looking for. You got to think. Huh? What's wrong with the size? Okay. Look closely at the 1991 soccer ball. You could just about put one of those in one of the octagons on the big soccer ball, right? So let's count how many soccer balls you can put in that big soccer ball. Let's see. There's, just on the face, there's 1, 2, 3, 4, 5, 6, 7, 8. Let's not count that as 8 or 7. Count these two as 8. Maybe that one is 9. And I'll just stop there. This ball is how many times bigger than this ball? 9 times bigger. But the difference is only what? 4 million. So this is a very bad representation, and this is kind of what you see in magazines and in papers. How many of you read magazines and papers with these types of pictographs in them? You always got to be careful because you got to look at the numbers versus the pictograph, because you might have some non-math person in graphics of that newspaper or that magazine who don't know what they're doing. Or they're trying to be biased. One of the two. Yes, sir. Yeah, bias. There's one with OIL drums. What's wrong with this one? Well, I don't know what's wrong with it. Yeah, there's nothing. You can't. That's stupid. Look at this one. Let's see. 30 and 20 is 50, 60, 72, 84. Up. 84 and 17. Doesn't add up. So this one I don't think is right because it doesn't equal what? Check it and make sure. I think I added right. I think it's around 101% or 91%. My head's starting to hurt, so I didn't have my Mountain Dew this morning. I think there's something outside that's messing up people's sinuses because something's going on with mine, huh? 104%. So that doesn't that look pretty to you? It looks like it's what? It's good to go, but it's not. Okay. Question. Here's some others. You'll have to look at those. What is misleading about this? Well, I don't know. It says steps needed to burn calories. 3,200 20 steps for a beer, 3,450 for a Coke, cheeseburger, 7,590, and a donut, 5,000. Well, it looks like the proportions are all messed up, doesn't it? Okay. First of all these should be regular size. How many of you know a cheeseburger that's the size of a donut, or a donut the size of a cheeseburger that's bigger than a soda, a can? That don't look right. So this should be smaller. All these should be up at the top, and they should be smaller. They should be in proportion to their regular size. And it should it should have one of these on it, one of these gray things. See, it's just misrepresentation. This one, 3,000. This is 3,000. 50,000. So this is misrepresentation because this 4 and this is 50. You should be able to fit 4 of these into this one, 4 or 5 of them into this one. So you could say that's a little bit off. Question. All right, so I'm gonna cut it off there.